This video is intended to explain to you how to factorise quadratic equations. If you're anything like me, then you probably started off with this. You probably started off with trying to factorise things that look like this. X squared plus 8x plus 12. And if this was a difficulty axis, then this is down here. And then one day your teacher would have introduced you to stuff like this. And the difficulty suddenly does this. And there's a lot of people, especially when they get to A level, who have great trouble in making this transition because this is a complete sort of step change in the difficulty of factorising. The rules and the sort of little techniques that most people use to deal with this just don't really work very well on these ones. So this is an attempt to try and help you understand and make that transition and to make it as easy as possible, because it is true to say that mastering this sort of stuff is really at the core of AS maths, and using it confidently turns up even when you get well into A2. So let's start with the easy one. Let's start with x squared plus 8x plus 12, and we're just going to contrast that with the difficult one on the other side. I should point out that if you don't know how to do them, then they're both difficult, and that's completely reasonable. But you'd want to start with the easy one first. Now, the thing about this one is that most people quickly get the idea that it goes into two brackets. And the same over here. There we go. And they also quickly get the idea that there's an x in both brackets. Now, when you go from there, you're using the fact that you know that the first two things multiplied together give you that, and you also know that the last two things multiplied together are going to give you the number 12. So most people's strategy for these relies around looking at the number on the end and figuring out the factors, which are, of course, 1 and 12, 2 and 6, and 3 and 4. So this highlights the first thing. If your times tables, your multiplication tables, aren't very good, you're going to have trouble with factorising, because you're not going to look at this number and see its factors. Pardon me. Now, normally what people do next is they then look at the middle term, the 8, and they say to themselves something along the lines of this. I know that 2 and 6 makes 8, so that means that it's 2 and 6. And we know that 2 times 6 makes 12 because it came from this list of factor pairs here, and then they think about the signs and figure out the rest. And that's usually where most people are at. That's the straightforward thing here. Wise people, the students that go on to more success, are usually a little bit paranoid. They usually check they've done it right by multiplying out x times x plus 6 times x plus 2 times x plus 12, and of course that makes plus 8x plus 12. And as people get better, they realise they don't need to be paranoid about these ones perhaps, but then they start getting paranoid about different things, like, for example, when you have negative signs in it and they multiply it out because they're not trusting themselves to get it spot on when they've got negative signs floating around. And that's very, very wise to check your answer. And if you don't check your answer to a factorisation, you're asking for it to be wrong. Now, over here, we've got a different kettle of fish, because you've got these numbers, the coefficients of x squared, and there's obviously the constant at the end. Now, this immediately complicates things, and it doesn't take long to figure out why, and this is it. So, first of all, it's easy to figure out that there's an x in both of them, because that's the only way you're going to get an x squared. And in fact, for this particular one, it's quite easy to figure out what numbers must go on the end, and that's because 3 is a prime number. And we know that these two numbers are where the constant, where the 3 comes from. Everything else has an x in it. These two numbers, when you multiply them, they're the only way you can get the constant. So, very easy when it's a prime number. There's only one way to make 3, 1 times 3. So, that is nice and straightforward. In this case, though, it's the 6 that's not very straightforward, because there's lots of ways to make 6. I could have 1 times 6, and I could have 2 times 3. Now, you might say, well, okay, that's only two ways to do it, but actually that's more complicated than that, because you could put the 1 here and the 6 here. Or you could put the 2 here and the 3 here. Pardon me. Let's get to that. Now, the problem really comes from the fact that the way round is actually important, because if you put the 3 here and the 2 here, you'll get a different answer. Why is that, I hear you ask? Or you might already know the reason. Well, the reason is very simple. This and this multiply to make the 6. So the order of the 2 and 3 doesn't matter to make the 6. But the number in the middle, the 7x, which we'll underline in green, comes from 2 terms. It comes from the x term here times the constant, and it comes from the x term here times the other constant. At this point, I'm detecting my explanation getting slightly ground down now, so bear with me. I might try another way in a minute. So the 7x comes from the 3x times the 3, and the 1 times the 2x, or the 2x times the 1. And if you switch around the 3 and the 2, then you get something different. What you get when you switch them around is the 2x times the 3 and the 3x times the 1. And of course those give you different results. 3x times 3 is 9x, and 2x times 1 is 2x, and they together will make 11x. And 2x times 3 is 6x, 3x times 1 is 3x, and together they make 9x. So the whole reason that this is more difficult to factorise is because the numbers here, the factors, the order matters. And of course, if we had more than one factor here, then the order of that would matter too. So you've got a lot more combinations. So what do you do about that? Well, there's 2 main approaches, and you have to suck up one of them. There's no option. You either go for trial and error and try out loads of different options, and that's not as bad as it might seem, because as you go along, as you try out different options, you will begin to build an intuition of how it works. You'll begin to be able to feel your way towards the result, as I'm sure you've probably seen people in your class do, and it's jolly annoying, isn't it, when they sit there and they go, oh, it's 2x plus 1 and 3x minus 4 or whatever. And it's very frustrating because you're thinking, how the heck did they do that? Well, you can get there too. It just takes a while. It takes some practice. So you can go that route. The other route you can go is there is a method. There is a series of steps you can take that will, without a doubt, solve any one of these. A bit like you've got a method for solving the easy ones. So you could use a method. And it's really up to you which one you approach. It depends on your personality. Both of them require practice. Both of them require you to think and to make sure that you've got it securely established. You can't just expect to see it. If you can see these, then this video is not for you. You don't need to worry about this. So let's try the trial and improvement method first of all. So I'm just going to go through the options, and you have to be, if you're prepared to do this, you will succeed. Now, I'm not going to worry about the sign for this moment. Let me get rid of all these horrible little lines here. There we go, and that one as well. Off we go. Right, so I'm going to start off with that one. I'm going to write it down. X, I know it's negative here, which means that one of them is going to be negative. That's positive. I think the big number is going to be positive, so I'm going to go for negative 1, and then I'm going to go for 6x plus 3. And the thing about the sign is you can adjust it later. Okay, so we've got x times 6x, that's 6x squared, plus 3x minus 1 times 6 minus 6x minus 3, and we can see that the 2 middle terms there are going to give us minus 3x, not 7x, so it's not that one. So we just carry on. Not giving up is the key to this. Now remember, we can try them the other way around. 6x minus 1 and x plus 3. So I've done the same thing the other way around. And this time I've still got my 6x squared. This time I get my 6x times my 3, so that's positive 9x, and then minus 1x, minus 3. And this time the two middle terms give me positive 8x. Well, it's closer, but it's still not 7x. So we carry on. Now, I've used up my 6 times 1, now I'm going to do my 2 times 3. So I'm going to have 2x minus 1, and then 3x plus 3. 2x times 3x is 6x squared, as before. 2x times 3 is positive 6x. Minus 1 times 3, minus 3x. And then we've got our minus 3 at the end, and those two there make positive 3x. Still no luck. Better hope the next one works. If the next one doesn't work, I've made a mistake somewhere. Switch the 2 and the 3 around. Plus 3. Okay. Right. 3x times 2x is 6x squared. Getting ahead of myself there. 3x times 3 is positive 9x. Minus 1 times 2 is negative 2x. Minus 1 times 3 is minus 3. And this time, positive 9 minus 2 is positive 7x. So I know, and you have to be pretty unlucky to get it on your last go, I know that that is the correct factorisation. Okay, so notice that didn't take me very long. All I had to do was just multiply it out, and if you can't multiply out quickly, you need the practice. It's a fundamental A-level skill. It's a pretty fundamental GCSE skill. You just need to be dogged enough to get on and do it. Now, let's have a look at the other method. This is the sledgehammer method. So, how do I factorise 6? Oh, let's just go back to black. That's not very pleasant, is it? Okay, how do I factorise 6x squared plus 7x minus 3 with none of this frustrating guessing business? Well, there's quite a few steps to this. It can be proved algebraically, and initially it's just going to seem like a magic formula. So first of all, I take the 6 and the minus 3 and I multiply them. The 6 is the coefficient of x squared, and the minus 3 is the constant. And that gives me minus 18. And now I look for factors of, and I'm going to go for 18 and then think about the sign later. So that's pretty straightforward. That's 1 and 18, 2 times 9, 3 times 6, and that looks like it really, doesn't it? Now, I'm going to look through these factors for a pair that can make 7. Now, at first glance, it doesn't look like I've got in a lot of luck there, because I've got 1 and 18, that makes 19, 2 and 9 makes 11, 3 and 6 makes 9. But remember, actually, it's minus 18 I'm trying to make. So I could have, so basically one of the numbers in the pair has to be negative. So I can't make 7 using 1 and 18, whatever I do to them, but I can with 2 and 9. And to get positive 7, I need a positive 9 and a negative 2. So that is my magic pair. Now, once I've got that pair, I can split the 7x into 2 terms. It doesn't matter which way around you do it. I'm going to have a minus 2x, positive 9x. So I've split the 7 into minus 2 plus 9. And then I put the other bits on. Now, I've got two halves to this. I've got this bit here, and I've got this bit here. I'm going to include the sign there. Now, I'm going to factorise it. Now, 2 and 6 are both in the 2 times table, so I can take 2 out, and they've both got an x in them, which leaves me 3x minus 1. Now, over here, both in the 3 times table, so I'm going to factorise a positive 3 out, and that leaves me 3x minus 1. And that's a really good sign because I've got the 3x minus 1s. Now, to finish off, I'm almost there. I've just got to factorise this out, and that leaves me with this. It leaves me with 3x minus 1, and then 2x plus 3, which, as you'll notice, is the same thing that we got using trial and error, but it didn't take very long. Now, I've already said that only someone who's, well, if you're not paranoid enough to check by multiplying out, you deserve to get it wrong. So I'm going to follow my own advice here. I've got 3x minus 1, and I've got 2x plus 3. I've actually already done it, haven't I, above? So 3 times 2 is 6x squared. 3 times 3 is positive 9x. Minus 1 times 2 is minus 2x. Minus 1 times 3 is minus 3. And then that leaves me with 6x squared plus 7x minus 3. Be aware of and look out for the usual mistakes people make. For example, they accidentally add instead of multiply, so they'd have 3 times 2 is 5. No, it's not. Or you mess up signs, that's also very common. Be very, very careful, because you want to get it right first time, and you want to know it's right so you can not worry about the next bit that you're going to do.